This is the second of a series of videos about one sample mean hypothesis testing. It's be very similar to the previous example where we're keeping things very simple. Given values for this one, we'll have y bar, the sample mean, at 11 this time. We'll leave mu at 10 again. Sample standard deviation is now 4 and the sample size is 25. Another change that we're making here, the null hypothesis is still 10. However, the alternative is asking, is the measured value of 11 significantly different from 10? So this makes for a two-tail test. Whenever you're asked about a difference, you are going to choose this as the relational symbol between the parameter and the value. And that means at the end we'll be doubling our p-value, which will then compare to the level of significance, which again is at 5%. Formula is the same. T on n minus 1 degrees of freedom is y bar minus mu divided by the standard error s over square root n. All right, let's put our numbers in. We have test statistic t. Sample size is 25, so degrees of freedom is 24. Now, let's put that in a slightly different spot. That's kind of in the wrong spot there. 24 should be down here. Okay, what do we have? We have 11 minus 10, 4 over square root 25. So this is 1 over 0.8. which is 1.25. So this is our test statistic this time. Now, we're going to go to the t-table, find row 24, and see where this value appears on the table, because that'll guide us to the p-value. So here is row 24. But our test statistic is smaller than the smallest value here. T equals 1.25 is off here on the left-hand side of the table. So let's go to the top, have a look. Here's our two-tail probability. So all we can say is that our p-value, whatever it is greater than 0.20. And we'll go back now and see how that compares to the level of significance. Well, it's clearly larger, and that means we fail to reject the null hypothesis. When the p-value is greater than the level of significance, we fail to reject the null hypothesis. So the conclusion here at the 5% level of significance is that there is no evidence that our measurement of y bar is equal to 11 is significantly different from the expected mu of 10, which is just another way these tests work out. We'll do a couple more of these and then we'll move over to confidence intervals and see how things compare.